This is Pat Caplow. I'm reading problem number 2 on page 98 in chapter 4, a net force of 265 newtons. I like the way this problem begins because they explicitly say that the net force is 265 newtons. They're not using generic terms like a force, but specifically the leftover force of 265 newtons accelerates a bike and a rider at 2.3 meters per second per second. This is these are units and information that you're used to seeing from previous chapters, acceleration in meters per second squared. So we have the net force and the acceleration. What is the mass of the bike and the rider together? This is an application of Newton's second law. Newton's second law, of course, can be written in a couple of different ways. One of the ways is using the sigma notation. Sigma F is equal to ma, or the sum of the forces is equal to mass times acceleration, or F with a net, net as a subscript, is equal to ma. We'll often be talking about this so frequently in class, we'll just say F equals ma, but we mean it's implied that we're talking about a leftover force. So if I were to solve this problem, and I can clearly see that I'm solving for m here, so I'm going to rearrange the equation solving for the mass of the bike and the rider together. It's going to be the net force divided by the acceleration, or in this problem, 265 newtons divided by the given acceleration of 2.3 meters per second squared. And the mass of the bike and the rider together are going to be 115 kilograms. Notice that the units of mass are kilograms. The units of acceleration are meters per second squared. When you multiply those two things by each other, you get a kilogram meter per second squared. I'll write this in separate units down here on the bottom. So you get a kilogram times a meter over a second squared. That is equivalent. These fundamental units of kilograms, meters, and seconds, these right here, create this derived unit called a newton, a unit of force. That's also something important to see. But as far as this problem is concerned, that's all you needed to know, 115 kilograms.